Hello students, welcome to another video.
Good evening, sir. How are you?
Yeah, I'm
गुड इवनिंग सर। सर आपको सेकंड ईयर की एग्जाम आती है?
yes.
सर सेकंड ईयर की एग्जाम आ गई।
Okay, so you are busy with your exams then.
Good evening, sir.
Good evening everyone. Welcome.
Good evening, sir. सर मेरे को कुछ पूछना था। हेलो
Yes, yes,
सर, क्लिपिंग वाला टॉपिक कहाँ से करना है सर? मेरे को थोड़ा और पढ़ना है क्लिपिंग के ऊपर, क्योंकि वो थोड़ा कम समझ आ रहा है, मेरे को डाउट है उसमें। तो वो कहाँ से पढ़ना है? मुझे रीड आउट भी करना है, तो किस बुक को फॉलो करना चाहिए उसके लिए?
let me tell you the book. This book is best for that of electronic devices and circuit theory by Boylested and Nishinsky. In fact, I have taken some problems from this book. Good evening. Okay.
तो सर क्लिपिंग इसमें मिल जाएगा, क्लिपिंग वाला टॉपिक?
Yes, yes.
ओके सर, थैंक यू।
So we were discussing Maxwell-Boltzmann law of molecular velocities.
सर कैन यू एक्सप्लेन व्हाई वन वी कर्व इज सिमेट्रिक एंड ये नेक्स्ट प्रोबेबल वेलोसिटी इज 0 वन डी स्पेस?
But we derived that in, I think I have actually proved it that why it is 0.
सर यस सर, डेरिवेशन नहीं चाहिए, बस एक बार बता दो कि ये कर्व सिमेट्रिक क्यों होता है, रीजन।
Because it is 1D, that's why, because the particle is capable of moving both in negative x direction or positive x direction. That is the reason. And there is an this kind of term was there.
यस सर।
To study in detail regarding this term, this corresponds to the Gaussian function. Okay, the whole game it is based on this function actually, and it is bell shaped. Gaussian means bell shape. Normally it is called bell shape, and that's why the shape of the curve was like that. Remember this kind. It is like bell,
यस सर।
the bell that is used in temples and all. And because it is Vx square only, so it is symmetrical around Vx equal to 0, and the maxima lies here. Okay, it is having two things are clear from this expression, that it is symmetrical around Vx equal to 0. Because if this contains something like this, Vx minus suppose k square, then we will say that this curve is symmetrical around Vx equal to k. But right now it is Vx square only, so it means it is containing a factor 0 over here. It means it is symmetrical around Vx equal to 0, and the maxima of the curve it lies here. And we know that when we plot this Maxwell-Boltzmann curve against the velocity, then the maxima it corresponds to most probable velocity, isn't it? So that's how you can say that the most probable velocity is 0 if you don't want to prove it by definition. Okay.
ओके सर, यस सर।
So you can read about this term. This term you will come across in quantum mechanics also while studying harmonic oscillator. Yes, in quantum mechanics when you study the topic of harmonic oscillator, the wave function of the harmonic oscillator they also include this exponential factor. Okay. Now let us try to have the expression for the Maxwell-Boltzmann distribution in the form of momentum and energy. So earlier we wrote the expression in terms of velocity only. Okay. So Maxwell-Boltzmann. Yeah, Usman, we will discuss about real gas also. Don't worry. Maxwell-Boltzmann distribution law in terms of momentum. So again, I will be writing this for 1D, 2D, and 3D cases. So let us write it for 3D case first of all. So do you remember the expression for 3D case? It was like this, or you can write only PPDV over here, like this. 4 pi b square dv. Remember? Now we know that P is equal to mp, so dp will be mdv. So in order to convert this into momentum, the left hand side will get converted to ppdv, and now it represents the probability of the particle to have momentum between p and p plus p. Okay, probability of the molecule or the particle to have momentum between p and p plus p. Okay, so we have to change only terms containing v to p. So v is p by m. So this term will become mp square by 2kt m square, because v is p by m from here. Okay, and dv is dt by m. So 4 pi square by m square dt by m. Okay, is it clear? Is it clear or not?
चलिए सर।
So now this becomes m cube now. This. Okay. And there is m raised to power 3 by 2. So we are left with m raised to power 3 by 2 in the denominator. Isn't it? So 1 by 2 pi m kt raised to power 3 by 2. P square by 2 m kt. 4 pi p square dp. Okay. So this is the expression now we are having in 3D in the form of momentum. Clear? Of course, you can adjust these factors also if you want, but there is no need. Clear to all? Now, what do we have for 2D in the form of velocity? So PdV was m by 2 pi kt e power minus mv square by 2 kt 2 pi dv. Now try to convert this also. Of course, now we have seen that this expression, it becomes p square by 2 m kt. So we can write it directly, and this will be 2 pi, and this will be p by m, dp by m. So a factor of m square is in the numerator, so again it will become 1 by 2 pi m kt. So e power minus p square by 2 m kt, 2 pi dp. Here, please keep commenting me so that I get to know. Clear or not?
Yes, sir.
Yes, sir.
Yes, sir.
Similarly, now we can go for 1D case also. So for 1D case, we were having pdx, dx. So it was m by 2 pi kt square root. So e power minus m dx square by 2 kt dx. So now it will become ppd or ppx dpx. You can write, okay? So whatever you feel convenient with. Obviously, when we are saying that it is 1D case, so it will be only one component of momentum because particle is capable of moving only in one direction. So px square by 2 m kt dpx by m. So again, we can adjust this m. So it will become 2 pi m kt square root e power minus px square by 2 m kt dpx. Okay. Of course, you can write dpx dpx over here. So now this is the exact one. So this way we can convert the expression that we were having in the form of velocities to the expression in the form of momentum. And similarly, we know that sometimes for that purpose we might have to. Okay. So how we can get this expression in the form of energy of the molecules? So let us see. So what will be the procedure? So now we are having two kinds of expression in the form of velocity and momentum. So how we can convert them into the energy expression? Anyone? Anything that comes to your mind? Just as we use the expression between momentum and velocity to convert them. Yes, speak up.
Energy equal to half mv square. Kinetic
Energy.
energy.
Yeah, either you can use half mv square. Okay,
Mv
or
square by 2m.
p by 2m, or you can use p square by 2m. So then you can convert the expressions in the form of momentum to energy. No, energy not equal to momentum into velocity, it is wrong. So where will that half factor goes? That way it will be half mv square only. For units, this is okay, but this is not the exact one as far as mathematical formulation is concerned. So Maxwell Goldman distribution law. Energy. So now we know that E is equal to E square by 2m. So dE will be 2p dP by 2m. So P by m dP. So dP will get converted to m by p dE. So P will be like 2m square root. So it will be m by 2 e square root. And from here we get 2m equal to e square. So P is equal to 2m. So this way we can convert P to E. So this is the general thing. So this we will be using for all the three cases, whether it is 1D, 2D, or 3D. So now let us first of all use it for 3D. So now we will start from this expression that we have derived for 3D. Okay. So you need to remember this expression. So it is 1 by 2 pi m kt 3 by 2. 2 pi m kt 3 by 2. E power. What D? So DE, it will become. So P square will be 2m, P square by 2m. We can straight away replace P square by 2m. So it will become E power minus E by kt, and P square will become 2m, and dP was m by 2 E square root dE. Okay. So this m raised to power 3 by 2. So you can see this is m raised to power 3 by 2, and this is 2 raised to power 3 by 2 along with this. Okay. So this will become m goes 2 goes, so pi kt raised to power 3 by 2. So 2 pi root ed. Please check. Is it?
Yes, sir.
Kindly check this out. Is everything okay? According to me, I think. Because this will be 2 root 2 now. And this is 4 root 2. So only 2, a factor of 2 will be there. Of course, we could have adjusted pi also, but there is no need. Clear?
Yes, sir.
For 2D, what was PPD? It was 1 by 2 pi m kt. square by 2 and kt, 2 pi kt. So try to do it yourself. So 2 pi t, 1 square root dt. This one t. Yeah, it seems good. So now, what will happen? This 2e factor will get adjusted at 2e square root, and m will get adjusted with this, and 2 pi. So let me cancel these. This 2 pi with this 2 pi, this e with this e, this 2 with this 2, and this square root m with this one. So we are left with only 1 by kt e power minus e by kt d, isn't it?
Yes, sir.
Okay. Clear to everyone?
Yes, sir.
Now for 1d case. What was the expression for 1d case? 1 by 2 pi m kt square root. E power minus px square dpx. So px square by 2 is again e by kt, and dpx was m by 2 e square root e. That's it. So square root m will get adjusted. So we are left with a factor of 2 in the denominator. Okay, or we can leave it as 2 pi kt square root e power minus e by kt, and de by 2 e square. Okay, please check everyone.
Yes, sir.
If you have any
Yes,
doubt,
sir.
ask me. Clear?
Yes, sir.
That day we explored the 1D case completely. We discussed about the, I think, average velocity also. It was coming out to be 0. Then we explored about the most probable velocity. Okay, and then in fact we got the expression for RMS also, and then mod of Vx also. All these things we discussed that day.
Yes, sir.
So now I'm going to derive an expression for the average speed in n dimension. So I'm going to have a generalized formula for the average velocity. Okay, so then if you can remember that expression, then by substituting n equal to 1, 2, 3, you can get the expressions for 1D, 2D, and 3D cases. Okay, so average speed. As I said that day also, that you are not going to get this material in any book, anything. Okay, so this is self-made material. This is totally ours. So there were two expressions for average velocity. Na? One is for the normalized case, other is for the unnormalized case. So I'm using the formula for the unnormalized case. The benefit of using quantity because it is difficult. See, now if you are using this much expression only, even then you will be getting the correct answer, even if you drop out this term. Okay, that's why we use this expression. Now, for n dimensions, what is the formula for PVD? We wrote it that way in the very beginning. It is proportional to v power n minus 1 e power minus mv square by 2 kt. So you can see I'm putting the proportionality sign because I'm not using the complete expression. I'm dropping out the constant term because this term is there in the denominator, so I need not worry. Okay, otherwise if you can remember that constant expression also, so then you can use this part only. Okay, so now substitute the value. This, and in the denominator it will be like this. Okay, so now I will give you the generalized formula for solving this kind of integral. So in the numerator it becomes v power n mv square by 2 kt dv, v power n minus 1 minus mv square by 2 kt dv. So now note down the generalized formula. 0 to infinity x power n e power minus alpha x square dx. It is half gamma n plus 1 by 2 divided by alpha power n plus 1 by 2. So now if I apply this formula on this term, this will become, you can see, 0 to infinity of half factor and gamma power is n. So it will be like gamma n plus 1 by 2 and alpha. What is alpha over here? Multiplier of x square, and x here is which contains power n, the term which contains power n, and here v is the term which is containing power n. So v is x square. So rest everything it constitutes alpha. So alpha power means m by 2 kt power n plus 1 by 2, isn't it? So this is regarding numerator only. So now we have to use it on the denominator also. So let me write it this way, oblique, because we have to write the denominator also, and I'm not having sufficient space. Now, for the denominator, it is power n minus 1, so it will be n minus 1 plus 1 by 2, and m by 2 kt power n minus 1 plus 1 by 2. Here, please check. These two will get cancelled, and this will be like gamma n plus 1 by 2. Can I write it at 2 kt by m power? I'm just reversing the terms. Can I do so? Please tell. Is it okay?
Yes, sir.
So now you can see here the power is n by 2, and here it will be, if I subtract this power, it will be n by 2 plus 1 by 2. So I'm left with 1 by 2 power only, because n by 2 power will get cancelled. So it is 2 kT by m square root, and then this term in general. Okay, clear? So 2 kT by m square root accompanied with that gamma. So now this is the general expression. We cannot do anything with gamma right now because we don't know the value of n. So now we will substitute n equal to 1 to 3 to get the formula for average velocity for 1D, 2D, 3D cases. Okay, clear up to this point?
Yes, sir.
Yes, sir.
This formula is very important. You need to remember this. Very handy. So for 3D cases, n is equal to 3. So average velocity will be 2 kT by m square root. Gamma 3 plus 1 by 2. Gamma 3 by 2. So it will be like 2 kT by m. It will be gamma 2 in the numerator. And in the denominator, it will be gamma 3 by 2. It is 1 factorial. 3 by 2 will be half root pi. We did it last time also. Isn't it the same expression that you see in the books? But there they derive it by totally different methods. A lot of mathematics is there. But now just by solving one expression, we are getting the formula for 1D, 2D, 3D, all cases. Okay. So now what will be the formula for 2D case? The 2D case m is equal to 2. It will become 2 kT by m square root. Gamma 2 plus 1 by 2 by gamma 2 by 2. 2 kT by m square root. Half root pi, gamma 1 is 1. So pi kT by 2m square root. This is the expression. Okay. Clear?
Yes, sir.
Yes, sir.
1D. But now for 1D case, you need to remember. Now you will say that, sir, in 1D case, average is 0. We did it that day. But here, this average actually means average of this point, average of the mode, and this one non-zero. If you recall from last lecture, this quantity is not zero. It's non-zero. Remember?
Yes, sir. Sir.
Now we derive now for average of mod Vx.
Yes, sir.
So these are the formulae for the average. Now let us again calculate it for VRMs. So again, I will be doing it for the n-dimensional case, and then by substituting the various values of n, we will get the expressions for 1D, 2D, 3D. Okay. So now the root mean square velocity of speed. So VRMS is V square mean and then square root. So let us first of all calculate the mean of V square. So it will be 0 to infinity V square, e power n minus 1, e power minus n V square by 2 kTd. So 0 to infinity e power n minus 1, e power minus n V square by 2 kTd. So this becomes e power n plus 1. Now again, you can make use of that shortcut formula that I have written on that side. X power n. In fact, denominator is same and we have solved it already now. So you can write its value directly from the earlier expression. So now I'm straight away writing that the m by 2 kT factor in the numerator by reversing it instead of writing it in the denominator. Okay. So I have combined two steps because we have seen it earlier. So it will be like this one. It's half of vector got cancelled. Now we are left with 2 kT by m because this will become n by 2 plus 1 only, and n by 2 power will get cancelled, and this will again become gamma n by 2 plus 1. Okay. Clear? So 2 kT by m gamma n by 2 plus 1. Therefore, VRMS, which is square root of this quantity, it will be n kT by m square root. And now we can get expressions for 1D, 2D, 3D cases by substituting various values of n. Okay. For 3D case, 2D case, 1D case. For 3D, n is equal to 3. So VRMS will become 3 kT by m. For 2D case, n is equal to 2. This becomes please check. Is it okay? Clear or not?
Yes, sir. Clear, sir.
So now we are left with which velocity? We have done it for average and RMS. Third one is which velocity? Who will tell?
Most probable.
Most probable, yes. Most probable velocity or speed. And most probable velocity is given by derivative of PV when we put d by dv of PV equal to 0. And this is 0 at the velocity, which is called most probable velocity. So this gives d by dv of v power n minus 1 e power minus mv square by 2 kt equal to 0. So this will be like n minus 1 v power n minus 2 by parts. This exponential factor can be taken as common and v power n minus 2 also, because this is least of the two now. And we are left with n minus 1 minus mv square by kt. Of course, this cannot be equal to 0. Otherwise, PV will become 0. This is exactly the same thing that is being contained in PV. So it means only this quantity is equal to 0, which is in the bracket. This v is v most probable. Okay. Don't forget to put v most probable. This gives v most probable square n minus 1 kt by m. This gives v most probable n minus 1 kt by m whole square. Clear? Check please.
Yes, sir. Yes, sir.
Now substitute various values of n for 1D, 2D, 3D cases and check their formula. Are you getting the correct expression or not? This. Please check. Clear?
Yes, sir.
Yes, sir.
So now expressions for different velocities for 3D case in terms of its molar mass. In terms of molar mass, expression for in terms of molar mass. So V average was 880 by pi m. So can I write it as multiplying and dividing by Avogadro number? And this NA is R, it will become 8 RT, and this M into Avogadro number will become total molar mass, isn't it? It means by solving this expression, we have seen that if we replace this K by R and this small m by m, this expression will get converted into the molar mass form. So that's what I have done for RMS case. And similarly, for most probable, it was 2 kT by m. So it becomes 2 RT by m. Means I'm changing K to R and small m to capital M. Okay, please check. Clear to all?
Yes, sir.
So similarly, you can get the expression for 2D case also. You are having the expression now, you can do that. Now, again, I'm doing it for 3D case specifically now. Sometimes you are asked about the ratios of the 3 molecular velocities. Okay, so let us find that ratio. Obviously, first of all, let us see their order. Earlier also, I explained you about their order. I think this was the expression, particular plot, and these were the 3 velocities. Starting with most probable velocity, it is the least one. Do you remember? This was average.
Yes, sir.
RMS.
Yes, sir.
So the order is VRMS, the greatest of all, then V average, then V most probable. So now the ratio in this order, it will be expression for V most probable 2 kT by m square root, 8 kT by pi m, 3 kT by m. So of course we can cancel this factor of 8 kT by m square root. So we are left with this thing, and this comes out to be 1.414, 1.59, 1.73. This is their ratio. And similarly, we can do it for 2D and 1D cases. Let us see for 2D cases. For 2D, this is the maximum point. This corresponds to P max. That's why it is called most probable. Means that most number of molecules they possess this velocity. That's why it's called most probable. Now for 2D case, this one. And similarly for 1D case. First two are 0 of course. This was KT by m square root. KT by m. Yes. Yes. So simply it will be 0 is to 0 is to 1. But they can ask you in any order. So you have to be careful. Okay, it's not necessary that they will ask you in the increasing order only. They may reverse the order also, like this. V RMS, V average, V most probable, like this. Okay. Clear?
Yes, sir.
Now try to answer this question. Please get me this answer quickly. IIT Jan 2011. Yes, anyone? Very good, Kapil. Don't speak, only answer it over here. Very good, Arun, Divya.
Sir, A option.
I'm saying please answer it over here. Don't speak. Answer only in the chat box.
Oh, sorry, sir.
Then everyone can respond. It's wrong, Tamya. Please check it again. Very good, Rita. Yes, Sanju. But no one asked me that we have to find which speed. They are not mentioning about the speed. Na?
Sir, average करेंगे ना?
Why?
Sir,
Why?
3
So for any purpose, B is proportional to T, na?
Yes, very good. Here it does not matter because all the velocities they are proportional to square root of 10. That constant factor it will get cancelled out. Whether you try to find out most probable or average or RMS. So that's why they are not mentioning. Okay. So V is proportional to root T. It means V1 by V2. It will be T1 by T2 square root. And it will be 273 plus 27, 273 minus 73. So 300 by 200 square root. A option. Okay, clear? Because all the velocities they are proportional to square root of temperature. You can check their expression. And obviously it is 3D case because the molecules they are in container. So don't think that it is 1D, 2D or 3D. Now next one. Vessel. Equal number of molecules. Try to solve this one. Equal number of molecules of two monatomic gases. Only the mass difference is there, nothing else. So we have to get the average velocity. Very good, Kapil. Yes, Mamta. Good. It's wrong away. Yes, Yashri, it's correct. Hurry up, everyone. See, first of all, calculate the average velocity of the molecules of both the gases. For gas A, let us denote the average velocity by VA1, and it is equal to this. And for gas B, because M is 4M, so VB bar, it will be 8 kb by pi into 4M. So it will be half of this quantity. That is VA bar by 2. Please check, everyone. Average velocity of the molecules of gas B, it is half, huh?
Yes, sir.
2 times. So now we have to take their average. So average velocity, therefore average velocity of the atoms in the mixture is this. So this will be 3 by 4, 8 kb by pi m square. So option A. Check, everyone. And let me give you a generalized.
Molecules were different.
Your voice is breaking. Please speak again.
What if the number of molecules would have been different?
I'm telling you. Please wait.
Okay.
This. Clear?
Yes, sir.
Yes, sir.
Another question was there in chat. A tiny dust particle. Micrometer. Please write micrometer per second. Random billions. This one. So clearly they are mentioning about RMS speed. So it is 3 kb by m. So we have to substitute the values. Nothing else. Now solve it and tell me the answer. Yes, Tamil. This will come out to be 20 into 10 to the power -6, that is 30 micrometer per second. C option. Everyone, please check. Are you getting C option?
Yes, sir.
So that day we solved one different type of question, and I gave you the shortcut also for that kind of questions. Now tell me about this value. That alpha beta type of question was there. I'm not able to find it.
Sir, the video is still fixed.
Yeah, actually, I was looking for that kind of question.
Okay, sir. Okay.
I'm not able to find actually. I think I forgot to note down that. Let me check once. I just wanted to confirm from you. Yes, here it is. Tell me the average value of this Vx plus alpha V1. I gave you the shortcut at it. Let us see how many of you remember.
1 plus
1 plus alpha square.
This much only.
1 plus alpha. Yes, sir.
KBT by M.
Yes, it is accompanied by this term also, KT by M also. This is the answer. Okay. Don't forget about this factor. This is very important. Clear? Now suppose they ask you about this value. Then
1 plus
1 plus b square
plus
KBT
B
upon
square.
M.
okay. Then what about this?
0.
0.
Because this will be equivalent to this now.
Yes, sir.
So only it is 0. And what about this?
0.
Very good. Because this is 1D case. Clear?
Yes, sir.
And what about last? This. Of course, of this kind. What is this?
So still 0.
KT by M.
Is 0? How?
KT by M.
KT upon M.
It is square of root mean square now. It is non-zero. It is KT by M. Don't forget. You can check in your copy. This was KT by M. That's why VRMS was KT by M square root for 1D case. Now a simple question based on this. Vx, Vy, and Vz. They denote the components of the velocity along x, y, and z directions respectively. Of an ideal gas particle at the absolute temperature T. The average value of this product is proportional to T power 3 by 2 T cube T power 6. Let us see who is able to solve this one. Very good, Rita. Very good, Kapil. Good, Arun, Divya, Siddesh. It's wrong, Usma. It's wrong, Tamya. It's wrong, Ritika. C is right. Yes, Sanju, away, it's right. Yes, Tamya. It is C option. Just now we have solved it. If Vx square is KT by M, so there will be 3 factors of this kind now. We have to find the average of this now. So we can split this expression into 3 expressions of this kind. And each of this factor it will give us KT by M, KT by M, KT by M. So KT by M cube. And proportionality factor is P cube. That's it. Clear? Is it clear?
Yes, sir.
A spherical closed container with smooth inner wall contains a monatomic ideal gas. If the collisions between the wall and the atoms are elastic, then the Maxwell speed distribution function d and v by dv for atoms. This please note down. I will be giving you the other option on the next slide. Other two diagrams. Please note down the year. This one is from IT Jan 2016. Please tell me when you have noted.
Yes, I noted.
Everyone.
Yes, sir.
So which option is correct according to you? Only tell me in the chat box. Okay, don't speak. Very good, Mamta. Very good, Siddesh. It's wrong, Arun. Very good, Abhay. Yes, Divya. Good. Yes, Yashvi. Correct. Very good, Ishita. Very good, Kapil. Very good, Tamya. Yes, it is C option clearly. We have done it so many times. So C option is correct. So nothing to explain about it. What about this one? It's wrong, Rita. Yes, Divya. Good. Very good, Tamya. Usma, Siddesh. Yes, Rita. Good. It's wrong, Mamta. Yes, Kapil. Very good. Very good, Arun. Yes, Sumesh. It's wrong, Sanju. Yes, Nisha. Very good. Very good, Abhay. Yes, Ritika. So some of the students, they are not using that shortcut actually. What is the use of that shortcut if you are not making use of it? The answer will come from that shortcut only. So now the coefficients of Vx and Vy clearly they are 1. So the answer to this Vx plus Vy square will be 1 square plus 1 square kt by m. That's it. So it will be 2 kt by m. B option. Clear or not? Or otherwise also if you expand it, suppose you want to solve it by expanding like this, then you will get 3 terms. Even now you will get the same answer. There is no problem. This is kt by m. This is again kt by m. This is 0. Now we have done it so many times again. There is no point of getting the wrong answer. Clear?
Yes, sir.
Yes, sir.
Also, students, please revise this topic. Yes.
So what does it mean by classical gas? That is real gas.
Classical gas means which is governed by the laws of classical mechanics. That is, this Maxwell-Boltzmann law actually is classical law. It is not applicable to the quantum things. Okay. That's why it's called classical gas. There are two branches, na, classical mechanics and quantum mechanics. So this classical is classical mechanics, which obeys the laws of classical mechanics.
Okay, sir.
Okay. So okay, students, that's all for today. Okay, bye bye. Take care.
Thank you, sir.
Thank you, sir.